Okay, well here we go on this one. This is, as we look at this, we need to sit and ponder and say, okay, which of the variables is going to be easiest to get rid of? And there are some tricks you can do, and I won't necessarily do this because I don't know if everyone teaches this, but all of those are divisible by 4, so our first equation we could actually simplify. And I would do that if there was no other alternative, but I have this little z down here, which will be easy enough to manipulate. And so let's just call this, if this is equations 1, 2, and 3, let's just remind ourselves that we need in equations 4 and 5 that is missing one variable. We need to eliminate that variable. And I'm going to decide to eliminate z because this z is easy to turn into a -5 or a -4. I'm going to do that in both cases. Okay, I'm going to use some of the margins above and wherever we got space because this takes some space. So I'm going to start out with equations 1 and 3. However, I'm going to take number 3 and multiply it by -4. So that's going to allow me then to cancel the z's from both of those equations. Now 1 I don't have to alter at all. It's a -4x plus 4y plus 4z equals -16. And if I distribute a -4 through this equation, that's going to give me a 12x, a plus 8y. It's going to give me a -4z, and that's what we're shooting to do here. And that's going to equal a positive 20. So if I combine all those terms together, this is an 8x. Adding those, I get a 12y. This goes away, and that leaves me with a 4. That is equation 4, but just for the sake of doing what I mentioned earlier, the 4 goes into all of these. So I'm going to divide by 4 to make our life a little easier. I'm going to do the entire equation divided by 4. That'll give me equation. It'll be 2x plus 3y, and that'll equal 1. And I'm going to call that equation 4. It's the first equation I have that only has an x and a y. Now I've used 1 and 3. That means I have to use 2 here, and because I know that I can manipulate the z down here, I'm going to use equation 3 again. So I'm going to take equation 2 and equation 3, but this time I'm going to take equation 3 and multiply by a -5. Makes that a -5, so it'll cancel with that. -2x plus 5y plus 5z equals -14. If I distribute my -5 this time, this is going to be a positive 15x. It'll be a plus 10y. It'll be a -5z, and that was the point, to get those to go away, and then a plus 25. Okay, if I combine those two equations together, this is a 13x. This is plus 15y. That's gone, but it's equal to 11. 25 minus 14. I'm gun shy now after I'm making mistakes on that previous one. You don't want mistakes on this one, my people. There's no way of simplifying that. That's a 13x plus 15y, and that's equal to 11. Now, that's equation 5. We look at equation 5 for just a moment. 13 and 2 are not very compatible, but a 3 I can definitely turn into a 15. So let's take our equation 4, and the next bet here is to try and get rid of a variable, another variable. So I'm going to multiply this by a -5. Distribute that, that's a -10x minus 15y, and that's what we tried to do there, equals -5. Cancel that, I'm end up with a 3x equals 6, and if I divide by 3, I got an x equals 2. Now the cool thing about that is that already kind of narrows it down to that is my only option if in fact I've done things right. But I'm going to keep going. If I plug that 2 into either one of these two equations and they both work, this is going to be the easier one. The harder part is going to be finding space. I'm going to take that equation down here. So I'm taking 2 times whatever x value is, we happen to know that now, times 3y equals 1. Since I know x is 2, I'll put that in. That's 4. Subtract 4 from both sides. I get 3y equals -3. If I divide by 3, I get y equals -1. And honestly, on something like this, you plug in x and y, you're going to find z. You're really kind of narrowed it down to which is the one. Now another option would be to plug in -5, -1, -8 into all the equations and see if they work. That, is arguably as much or more work than doing what we're doing here. But I'm going to finish this and we'll call it quits and move on. -2 times -1 plus z equals -5. Now I could have gone back to any of the 3 equations, but I chose the third one because it looked like the numbers are smaller and easier to solve. That's a negative 6. That's a plus 2. And that's a plus z equals negative 5. That's a negative 4 plus z equals negative 5. If I add 4 to both sides, I get z equals negative 1. And so that clarifies we did that perfectly. So the answer is C. This one here is pretty straightforward. It's a combined like terms type of deal right there. And yeah, you can see that. Okay. Combined like terms, but you got to distribute the 3 first. So this 3c squared minus 6c plus 4 is going to, it's not going to equal anything. It's a plus. We are going to say plus the 3 times the 4c is a 12c squared. You distribute the 3 to that, it's a negative 15c. And distribute that, it's a negative 24. When we combine our like terms, you got a 3c minus plus 12c. Okay, that's a 15c squared. I'm talking about the c squareds there. You got a minus 6c and a minus 15c. That's a minus 21c. And when you do the 4 and the negative 24, it's a minus 20 because it's a difference problem and the larger number is negative. So the answer is A. What's a complete solution to this equation for number 34? I suggest that we rewrite this in 2 different ways. Write it as you see it without the absolute values, but write it as you see it without the absolute values, but a negative 3. Okay? Set it equal to 3 or negative 3, because if it was equal to negative 3, the absolute values would turn it into a positive 3. That's why we do that. Subtract the 18 from both sides, you get negative 3y equals negative 15, y equals 5. That's one of our solutions. That's not, and that's not. So the question is this a positive or negative 7? Well, I'm glad you asked. Subtract 18 from both sides, you get negative 3y equals negative 21. Divided by negative 3y is equal to a positive 7. Be careful. Oh, to forget that negative or that negative, you'd end up with a 7. You'd circle the wrong one and we'd think, oh, I circled it. Well, you get that one for free. But that's how easy it is to make a mistake if you're not careful. This is the new stuff. Concept 14. We're going to factor. Take out a y and a y plus 2. We're going to factor this. It's the difference of 2 squares, so they're conjugates. X plus 4, x minus 4. This is a divided by. We want to change it to a times, but if we do that immediately, we should move some stuff. Okay? The y squared goes down to the bottom. This goes up top in the form of two sets of parentheses. It's a y minus 4 and a y plus 2. Two numbers that multiply to get negative 8 add together to get negative 2. The x minus 4's cancel. The x, okay, looks like more was going to cancel, but that y will at least cancel with this guy here, leaving us with x plus 2 squared on top. Right? And on the bottom, we have a y times, other y's, I said x, times y plus 4. That looks like question A, or answer A. Find the zeros. We had a similar question earlier, but it said find the x-intercepts. It's the same question. 0 equals x plus and x minus, because it came out to be a product of a negative. Two numbers that multiply together to get 18 are 6 and 3, but a positive 6 and a negative 3 are going to give you that 3x. So x equals negative 6, x equals 3, positive 3. If we set them both equal to 0, subtract the 6, add the 3. There's your answer. It is answer D. Select the point that lies in the solution set for the system. Well, you could plug them in. To me, it's just easier to graph them. Although these graphs are not going to be that nice. You can do intercept form. Yeah, this is not going to be entirely pleasant, is it? The point that lies in the solution set for all the systems. Well, I guess we could plug them in then. There's a single point. If I plug in negatives, let's just see. You know what? Let me show you. 7y is less than negative 6x minus 9. If I graph this, divide by 7, it's going to be a general graph. If we have anything on near the line, we can always test that point, so that way we don't have to test them all. But you need to know how to graph. This has a y-intercept a little more than 1 in the negative direction. So that's going to be right around here and change. Okay, the slope though is down 6 and over 7. So it's almost a slope of 1, but a little bit different. Again, I think these points are going to be far enough away that we're not necessarily going to run into any problems. But if we go down 6, and over 7, it's going to have a slope that kind of goes that direction. Okay, down 6 and over 7. But it does say that we're going to shade below it. Y is less than. So we'll ultimately shade this direction. Back to that in a second. Okay, we also have the other equation, which is much easier to graph. Kind of, but not really. We have an 8y is greater than negative, this is going to be when we move the 2x over, it's a positive 2x. Oh, look what I did there. That's a plus 6. Holy cow. I had one mistake on the other. I was going to be unblemished here, but I made another mistake. My bad. So we still have the same y-intercept, but when I moved the 6x over, it should have become a positive 6x. So when I go up 6 and over 7, I'm going to go up 6 and over 7 that way. So it actually goes this direction. It still is shading downward, so I'll shade down below that and below that. So it's going to be in this zone here. When I move the 2x over, it becomes a positive 2x plus 6. When I divide by 8, that's an easier slope to deal with, but I still have a funny y-intercept. The equation is going to be y is greater than 1/4 x plus 3/4. Okay, it's a positive y-intercept about here, and then the slope is 1/4. So I'm going to go up 1 and over, or up 1/4 and over 1. I can do it that way, or up 1 and over 4. It's going to end up bringing me to about the same place. So the slope is going to be, and darn the luck, yet another issue. I hope you guys are catching this, and that would be, where's Waldo of mistakes that Mr. DuPont makes? Or I mean, Mr. whoever that voice is. I don't know who it is. Anyway, they're dotted lines because of the or equal to. Okay, so this one says I want to shade above. Y is greater than. Well, the bummer about that is that my graphing left us this little sliver of space up here. The nice thing about that is if we're plotting these points, it'll clearly fall in there or not. So -6, -7 is going to be way over here and way down there. That one's out of the running. 4, 2. 1, 2, 3, 4, and up 2. Well, that looks like that's a definite possibility. We'll investigate. -9 and +1, -4, -4. The nice thing about a graph like this and the points I've given you, the only real option we have is B. And if we were to plug that in to both, it would be true for both answers. Just to save you having to go through any more of this before we can just get this thing finished. 38. Which polynomial represents this? Probably the best way to do this would be to set up a box. -x minus 2 and x squared minus x minus 5. This is going to give me a -x cubed. If I distribute everything, I've got a positive x squared and a positive 5x. Now these negatives are going to do some things here. This is a -2x squared. That's a positive 2x and a positive 10. Diagonals are going to be like terms. So it starts out with a -x cubed. These guys give you a -1x squared. That gives you a +7x. And then that gives me a +10. So it looks like our answer is D. Thanks for sticking with me and for forgiving my mistakes. And that's what I meant to show you. All right.